Okay, so here's the third video under what I would call integration by substitution. Even though these next couple examples have no substitution in it, really. I mean, the second one does, but this question here could lead us to think that we would have to use substitution because of the sine x and the cos x, because quite often in an integration question with trig, you'll let u equal sine x because the derivative is cos x and vice versa. But in this case here, I'm just going to show you a little trick. Sometimes it's easier to simplify a polynomial, and I'm calling this one a polynomial because there's a squared in it, and I'm going to the binomial expand it out. So before I go and do the integral or the antiderivative of this, I'm going to say f of x. Obviously, I'm using a different notation here. And I'm going to multiply all this stuff out and distribute it all out. So I'm going to get sine squared x plus sine cos x plus sine cos x. So 2 sine x cos x when I distribute that. And then plus cos squared x. And of course, I can see sine squared x plus cos squared x. We know what that is. So that's equal to 1 plus 2 sine x cos x. I'm still thinking substitution because that's what we're talking about, but again, I see an identity this time. So if I can use an identity to simplify this, I will, and not have to do substitution. So 1 plus sine of 2x, and you can see now we don't have to use any substitution or anything like that because we can just do the integral of this itself, right? So the integral of this, f of x, is equal to the integral of 1 is x. The integral of sine 2x is negative cos 2x over 2 plus a constant. So it's just a different way of looking at a question, and I thought it was worthwhile doing an example of this so you can see how you can attempt questions multiple different ways. Okay, let's go look at this one. This one here, the first thing I notice is that this function here has a lower degree of a polynomial than the top. So the first thing I think about is simplifying, right? So I can try substitution, but again, I can see up top, I'm going to get 6x plus 2. It doesn't give me anything that's exactly the same. So again, partial fractions jumps in because it's irrational, but I don't want to do that either. So I'm going to try to simplify this if I can. So when I do this, I'm going to think of that x plus 2 equals 0. And I'm going to do some synthetic division because x equals negative 2 would be the factor of that. So I'm going to go and do that. So when I do synthetic division, out of the top, 3, 2, negative 4, and bring the 3 down, I get negative 6, which gives me negative 4, which gives me 8, which gives me 4. So now, the way this is going to look is like this. I'm going to split this whole thing as if I divided each term by x plus 2. Hopefully this makes some sense to you. That first one, we simplified. It's 3x minus the integral of 4. Now, you'll notice that it didn't work out. It didn't give us 0, but that's fine. That's a remainder, so let's write it like a remainder, plus the integral of 4 over x plus 2. Just like we would have done in pre-calc 40, this answer would have been 3x minus 4 plus the remainder of 4, still trying to divide by the x plus 2. But now, you've got 3 different integral questions, because just like limits, you can break up the sum of limits as 3 different sums, or limits of sum. The integral is the same idea. So I can do this one on its own. So again, the integral of that one is 3. Whoops. 3x squared over 2, nice and simple, minus the integral of 4 is just minus 4x to the 1 divided by 1, doesn't change anything. But now this last part here, this guy here, this is the part where it's its own question. So now I can't just do the integral of something like that, so I have to let u equal something. I have to use substitution. So this is why this is such a unique question, because I've got 3 different integral questions now, and only one of them requires substitution, so I do them separately. So du equals dx, like so. So I guess I should put the dx in here all the time, right? There should have been dx here, dx there, should have been a dx here, and should be a dx here. All right, so now I can go and start this question. So plus, I'm going to take the 4 out of here. This is just a constant, so I'm going to take that 4 out. So it's 4 integral of 1 over u, or du, over u, like so. So I'll do my question again. 3x squared over 2 minus 4x plus the integral of 1 over u is ln u, so 4 ln absolute value of u, which is just x plus 2, and then plus a constant. Sorry for squeezing it in there, but you can see how that's a pretty unique question, and it would take lots of time and effort to think about that. But the trick is understanding that the degree on the bottom is lower than the degree on top, and you can always simplify that to a certain point and then have a nice easy one on the end. Now we'll see this where it's not always going to work out quite so nice, where we're going to have to go a little bit further, but it's just something to keep in the back of your mind. When the degree in the bottom is less than the degree up top in a rational function, use synthetic division, break it down so that you can do integrals of nice, easy power rules. And you might have to still use substitution if you have a remainder, but sometimes it'll work out perfectly and just go to it.